Hi everyone, welcome to the module on fixing programs, aka debugging. There are many different errors that you might come across during your time as a programmer, and just a little overview on what sort of errors you can expect to encounter. So, base exception at the very top of this little table is pretty much like a class with all the different types of errors that a program can throw. So we're not going to go into details about the various different types of errors, but I will mention what these two are. So a keyboard interrupt is quite simple. It's when you as a programmer decide to stop the program by pressing a key either on the keyboard or on the mouse. An exception is an error that actually was caused by either the way you wrote the code or the way it was being run. And as you can see, there are many different types of errors that can be caused by this. So we are going to look through what a syntax error, semantic error, and logic error is. And these are sort of the overarching types of errors that you will most likely encounter when you're writing a program. So what do I mean by syntax error? It pretty much occurs when there is a mistake in the programming grammar or conventions. So it's like you know what you want the program to do, but the program doesn't quite understand what you're trying to tell it. So if we look at the example here, my name is Lalitha, uni is Monash, and I want to say if name is not equal to Lalitha, print who are you. But you see the red squiggly line underneath it? That means it's incorrect syntax. It means you haven't written the statement for the program to understand. But the right way to do that would be to use the exclamation mark and equal to Lalitha, because as we've learned in previous modules, when we want to say not equal to, we need to use the exclamation mark here. So if you were to run this program, this is what would print out. Syntax error, invalid syntax. It pretty much means go back, look through your code, make sure there's no sort of human language put in there that the computer can't really understand. Now, a semantic error is pretty much something that occurs when the syntax is all right, but you've done something you can't really do. Let's look through this example. My string equals semantic error coming through. My longest string equals my string plus 1. Now, it's a really common mistake that a lot of people make. They're just trying to add a string and an integer together, but Python doesn't really do that. You can only add strings together or integers together. So when you actually run this program, you see there's no red squiggly lines anywhere, so you can't really tell you've made that mistake until you've run it and you see a bit of red over here, and then it says here, it points out actually which line the mistake is in. My longest string equals my string plus 1, and it tells you it must be a string, not an integer that you're trying to add to the my string. So it tells you clearly where the error is and how you can fix it, which is why it's super important to actually read through your errors and find out which line they're in as well, so you can start debugging from there. So that's pretty much semantic error, where you're trying to do something that isn't very logical and the computer tells you so. The last one is a logic error. Now this one is a really sneaky error. It's just really hard to find out because there is literally no red squiggly lines anywhere, the program doesn't crash, but the wrong answer is given. So it's pretty much a mistake that comes in solving the problem in a wrong way. So if we look through this code over here, this program is trying to find the area of a rectangle, and so it has initialized length as 5, width as 3, and the area has been equal to length plus width, and print area. So the program runs, it even prints out the area as 5 plus 3, which is 8, but the answer is wrong. The area is actually supposed to be length times width. So this is a logic error in the sense that you made a little mistake in how you wrote up the program, but the computer doesn't really think of it as a mistake, because to it makes logical sense, because all it cares about is just adding an integer and an integer. So this is a really sneaky error, which is why you should be really careful in how you debug your program and make sure that you don't run into these errors that are hard to spot, because the program obviously doesn't tell you that you've made a mistake. On logic errors, there are different types of errors when it comes to loops as well. So because we've already done loops in a previous module, we're going to go through something called an infinite loop. So if we look at the code over here, so it has been initialized to I equals 9, and it says while I is less than 10, subtract 1 from the I, and then come back, check again, is I less than 10, subtract 1 once again. So this is actually an infinite loop because I will always remain less than 10. The condition over here will always return true, which means the loop will just keep running until infinity or until, well, the computer crashes. But this loop isn't really big enough to crash the computer. So let's just try running it and see how that goes. Okay, it's running. There's no output here because we haven't printed anything. It's running. You're not sure when it's going to stop. It's still running. So usually when a computer just keeps running all this time, you know you're probably in an infinite loop. So just to visualize things a little bit, what I'm going to do here is I'm actually going to print I to see exactly why we are in an infinite loop here. So if we run it, I'm going to stop it really quickly and scroll all the way back up here. So it has started printing at 8, so while I is 9 and it's gone in here, it's subtracted 1, 9 take away 1 is 8. Okay, it comes back, is 8 less than 10? Yep. Subtract another one, 7. Is 7 less than 10? Yep, subtract 6. And you see how it just keeps on subtracting and going on and on and on? All of these numbers will forever be less than 10, which means this loop will just keep on running. So this is a really important thing to look out for when you're dealing with loops. Make sure you account for any infinite loop conditions, which pretty much makes the loop keep on running and just never end. So that's one type of errors with loops. Here's another type. Also, just a quick note, the way I have been commenting and uncommenting is just select a whole block of code and do control// and control/ again to uncomment. So here the problem is we forget to ask for input again in a loop. So over here we've got my int equals integer input, please provide a number greater than 10. So we're asking for an integer input, which we then, well, obviously it's given in a string, and then we convert it to an integer. So now, while this integer is less than 10, print need a big number. Okay, so you've told us you need a big number, but can you please ask us for a number again? Nope. It's not done here, which is why this loop is just going to keep on running. So let's try this. So let's provide a number such as 3. There we go. That's just an infinite loop. Because when you first ask them for a number, if they don't give you a number greater than 10, like if they give you 3, for example, that statement is going to return true. You're going to come inside the loop, you're going to print need a bigger number, and then once you come back here, my int is still 3. You haven't changed anything. And so it's just going to keep coming back here, printing, checking 3 less than 10, printing. And so that's another type of infinite loop where you forget to ask for an input. So this is something that's really important to also look out for. And if you find that your program is sort of freezing, not doing anything, chances are you've forgotten to ask for another input. So that is that for errors, and it's super important for you guys to sort of look through errors, read through the messages and try and fix it, and also use the debugger in Pycharm to actually go through and try and fix the errors. You may ask, what is a debugger in Pycharm? So I'll quickly show how to use the debugger. Before I do that, with the infinite loop before, you've noticed how I've used a print statement to sort of visualize what's happening with my variable I. There is a better way to do it, which is to use the debugger in Pycharm, and that pretty much visualizes step by step how your program is doing and which way it is going. So we're going to try and use the debugger for the second while loop. So with a debugger, first thing you have to do is set a break statement. So that's pretty much when you choose a statement and you put a break next to it by clicking in this area. So for example, if I want to set up a break at this statement, I just click that and there's a red dot and a highlight. So that pretty much means that the program will keep running until it reaches this red dot, and then it stops there, and then it slowly lets us step through the program to see where it goes next. So let's try running that. And to use a debugger, make sure you click on the little bug and not the play button. So this is what the actual debugger is. So it says that. So it has already executed that statement. It's asking us for a number. Let's do 3 like before and enter. Okay, so it has stopped over here and it's opened up a little dialog box here. Here is where it's going to tell us all the variables that are being used right now. So over here we only have one, which is my int, and that equals 3, which is what I had typed in before. So now if you want to see where it goes to next, click the step over Okay, so it goes back to the while loop like we knew from before, and it's saying my int equals 3, so while that's less than 10, which it is, step over again, and it prints, and then step over again, and step over again. So you see how it just keeps going back and forth between the two. That tells us that this is an infinite loop, and it's because we forgot to ask for an input once again. So if you just keep stepping over, this is pretty much, and you see over here as well, it tells us what my int is because it never changes anyway. So this is what you can do to actually step over each of these. So main things to note here is to set up the break before you actually run it using the little bug here. And once you've done that, don't use the step into function unless you actually want to go into what the print statement does. Step over is just to go to the next line of your program. So just keep stepping over and that will pretty much tell you. Now this is a really simple program, which is why it just keeps oscillating between the two. But with more complex programs, you can set up a break where you think there's a problem, and then as you keep stepping over, it's going to keep skipping lines wherever it needs to go. So this helps you visualize the execution as it happens and tells you exactly where the program is headed to next and what the variable values are as well. So yes, using the debugger is a really, really good thing to start doing at an early stage because it's actually quite useful as you write more complicated programs, or if you want to work on assignments and you're sort of stuck and not sure how to go about debugging this. So yes, the biggest takeaway from this module is please do read through your error statements and try and locate the line where the problem is. Try and use, maybe if it's a simple thing, try and use print statement to see what's happening, or if it's a bit more complicated, do try and use the debugger to see exactly where the execution is going next and what the variable values are. So that's it for fixing programs, and see you guys in the next module.